So n is an integer greater than 1. All right, cool. Prove algebraically that this equation, which looks kind of mad, is always an even number. Well, I mean, I can tell you straight away what it is. An even number is something that's divisible by 2 or can be factorized as 2 times something. This is literally the result. We need to pretty much factorize 2 out of the equation, and wherever the something is, doesn't matter, as long as you got 2 outside. So let's do it. Let's solve and expand. So, expanding this entire expression, we're going to have firstly the first two, n squared minus 2. Expanding the bracket here, we're going to get n squared minus 4n plus 4. If you're not sure why I did that, this is just two brackets, n minus 2, n minus 2. Expanding this, you should get the same conclusion. Okay? Now, be very careful when you subtract, yeah? Because this minus sign will flip everything here. So just expanding it carefully, we're going to have minus n squared plus 4n minus 4. Good. So now we're out of that risky area. So now let's go ahead and simplify. So n squared and minus n squared cancel out, so get rid of them. And you're left with minus 2 plus 4n minus 4. So put it in correct form, we can say we have 4n and minus 2 minus 4 make minus 6. And we're done. Or we just factorize 2 out of that, so we get 2 times. Yep, my screen's messed up. Okay, now it's working. So factorizing, you should get 2n minus 3. And yep, even, because of this assumption. That's it. Moving on. Alright, number 17. Okay, it's too high up the camera. So, there are 9 counters in a bag. 7 are green, 2 are blue. Okay, so that's fine. Ria takes at random 2 counters from the bag and probably doesn't return it. Work out the probability that Ria takes 1 counter of each color. You must show you're working. It's very straightforward. So you just got to think of the colors. So if one of each color means she could have taken the green first then a blue, or she could have taken a blue first then a green. And you just find probabilities of both. So probability of taking the green counter first, well, it's 7 out of 9. Now because she's taken 1, she's got 8 left. And taking the blue, well, there's 2. Likewise, if you take a blue first, it's 2 over 9. You got 8 left. And taking a green, you got 7 at the moment. And you're done. And now you just evaluate and you just total up the probability and you get all that space to figure that bit out. So 7 times 2, which is, actually you can simplify the fraction. Always simplify first, guys, yeah? So, with my pen. So cancelling down 2 over 8, you get 1 over 4. So 1 over 4. And again, cross simplifying here, you get 1 over 4. And you just add them up now. So 2 times 1 is 7. 9 times 4 is 36. And this will probably give you the same result. And thanks to the law of total probability, we just add up the final result, which will give us 14 out of 36. Done. Very, very easy question. Okay, question 18, guys. So what do we have? So it says ABCD is a rhombus. Okay, so rhombus is practically a parallelogram with perfect lengths. Now the coordinates of A are 5, 11. So here is 5, 11. So let me just write that down here. The equation of the diagonal DB, so D to B, is given by this equation, y equals half x plus 6. So what I would do is first you draw a straight line. And there you go, call it y equals half x plus 6. Find an equation of the diagonal AC. Oof. So we want to find this diagonal now. Now, sometimes it's either obvious or you need to memorize the property, but one thing to know is that the diagonal in a rhombus are perpendiculars with each other. So both diagonals are perpendicular. Okay, due to their lengths being the same and whatnot. Anyway, let's have a look. So because it's diagonal, what does it actually mean? Well, first things first, this means that the equation of the line have perpendicular gradients, meaning the gradients are just very similar, just reciprocated with a change of sign. So for example, we know that the gradient of this line is a half, right? This automatically means that due to perpendicular lines, the gradient is now upside down and the sign changes. So it means it's 2 over 1 with a negative sign, positive negative, which is literally minus 2. Yeah, and that's all it is. So thus so far, our equation for that red line is minus 2x plus c. And thankfully, well, we're almost there. All we need to do is figure out any corners on this point, on this line, and find the value c. But thankfully, we have one. It's 511. We just plug in the values of 5 for x and 11 for y and solve for c. And yeah, that's it, guys. That's literally all you do. So to make this clear, we just say at point A, or at 511, we can say this equation becomes now, so y becomes 11, and x becomes 5, so minus 2 times 5, which is minus 10, plus c. And solving this one, plus and 10 across, you get c, which is 21. And we solved it, guys. We're literally done. So the equation is now, therefore, the equation of diagonal is y equals minus 2x plus 21. Done. Very easy, really. Okay, almost done, guys. Number 19. Oof, vectors. I love vectors. Okay, so OABC is a parallelogram. Okay, now this see the difference between these two is that rhombus have the same lengths, is a parallelogram with same lengths all around, and a parallelogram, of course, only has same lengths which are opposite. So since we know that the vector here is little a, this means this is also little a, because the way vectors work, if you move in the same direction and have the same size, you're practically the same. Likewise, OC, this is a vector c. That means above it would have parallel vector of c as well. Anyway, what else do we know? So x is the midpoint of the line AC. So great. So more lines. So draw another dotted line and call this one point x. OCD, I love that, is a straight line so that O to C and C to some imaginary D. So extend this line across. Is k to 1, so let's call this point D. So what does this mean by this ratio fraction? Suppose it said 2 to 1. This means that if it said 2 to 1, this would mean that O to C is twice the length of C to D. But what this means here is that O to C is k times bigger than C to D. This means that C to D is k times smaller. So we can say this vector is 1/k of C. Okay. If you haven't understood this, just write a comment below and we can discuss it. Okay, so far so good. Now, what do we need to know? It also tells us that the vector from x to D was D. So we're basically traveling from this point anywhere you want to D is given by this. Find the value k. All right, so what I would personally do is firstly find what x to D is in terms of what we have, and then equate it to this one and figure out k. Okay, so let's figure out what x to D is. So yeah, before we get x to D, let's find something that relates x. We can say straight away that because x is a midpoint, we can say if you're moving from, let's say, A to C, we can say that A to X actually is literally half the distance of A to C. So let's write it down. We can say going from A to X is literally half of A to C. Make sense? Let's go ahead and find A to C then. Well, going from A to C, you can go travel across this vector and go back. So it'll be plus C minus A. So it'll be C minus A. So that's literally the value of the vector. There's probably other variations, but this works fine. Now, what is the point of that? So now we can use this to get to D. So let's go from X to A to B, B to C, and D. So let's just travel all the way around to get to D, yeah? So we can say therefore X to D is going to be from X to A. So we know it's half C minus A, so it would just be the negative version. So it'll be minus half times C minus A. So this is the opposite side. Plus C minus A. So plus C minus A. And then plus 1/k of C. Plus 1/k of C. And yeah, now we just somehow tidy up. So let's collect everything in terms of C's and K's, C's and A's. So let's expand it. So we're going to have firstly minus half C plus half A plus C minus A plus 1/k C. Now collecting all your C terms, we have minus half plus 1C, which is 1/2C, plus 1/k, so we're going to have 1/2 plus 1/k C. As for A's, we have half A minus 1A, which is minus half A, so that's actually identical to the given that statement. Now, and that's pretty good actually. It means that we've pretty much found a perfect representation. We can see clearly that we've got minus half A, And we can actually realize that 3c must be equal to this quantity here because they're both xd's. So we can say all of these guys must equal 3. And yeah, now it's just a case of simple algebra. So now we just have to equate all that to 3. So we can say half plus 1 over k equals 3. What I would do first is combine the fractions here, yeah? Oh, you know what? Let's get to that later. Let's just say half plus 1 over k equals 3. Let's clear the fraction, yeah? Let's multiply k across. So we're going to have k over 2 plus 1 equals 3k. Times 2 across, we're going to have k plus 2 equals 6k. And alas, now we just solve for k. So now subtracting k across, you're going to have 2 equals 5k. Divided by 5, you get 2/5 equals k. And yeah, and that should be the answer. It's k is 2/5. Oof, definitely one of the longest vector questions I've seen. So yeah, pretty good.